Okay, this is a 4-fer taken from 3.3 on estimating square roots, and technically probably 3.4 as well, because the first question is probably a 3.4 question. So the first question, it gives you a right triangle, and it gives you squares attached to the legs of those right triangles. And it tells you that the squares attached to the two legs are 20 meters squared and 40 meters squared, respectively. And we know that if you take the area of the two legs and add them together, you will always get the area of the square attached to the hypotenuse. So we know that the area of this square will be 60 meters squared, right? So we know that that has to have an area of 60 meters squared. And in order to find its side length, which is what we're looking for, we need to really find the square root of 60. So the exact measurement of the hypotenuse would be the square root of 60. But we want to estimate what that distance would be. So we know that the square root of 64 is 8, and the square root of 49 is 7. And 60 is only 4 away from 64, but it's 11 away from 49. So probably around there would be a good place to put the square root of 60, which is probably 7.8-ish, roughly. If I take my calculator to verify, the square root of 60 is actually 7.7. So the approximate length of that hypotenuse is 7.7 meters long. Okay? 7.7 meters long. In the second question, you're given 11 and 12 on a number line and asked, right in the middle is the approximate square root of what number? Well, what you need to know is that the square root of 121 is 11, and the square root of 144 is 12. So if I think about this as being 130-ish, that's, 9 away from 1 and 14, so maybe 130 to anywhere with the square root of 134, maybe? Somewhere in that range, any answer you had of the square root of 130 to 134. And if I take my calculator and just double check with, let's say 132, I press square root, the square root of that is 1.48, which is roughly 11.5, which would have been the midway point between 11 and 12. So the best answer is probably 132, the square root of 132. In the third question, in green, it says the square root of 16 plus the square root of 20 is approximately what value? Well, this is a perfect square, and this is not a perfect square. So the first one we know to be 4, and the next one we have to estimate. The square root of 20 is probably pretty darn close to 4.5. If I take my calculator and go, what is the square root of 20? It is approximately 4.5. So because we're estimating, I could say plus 4.5 is approximately 8.5 is the answer I'm looking for. Okay? Roughly. If you add 8.4 or 8.6, those are good estimations as well. And finally, the last one says if you have a square and you know that its side length is 2.5, well, what I can do here is I know that here's 2 and here's 3. This is the square root of 4, and this is the square root of 9. So 2.5 would be roughly in the middle. And what would the square root that would be roughly in the middle? Well, probably something like 3 away, so maybe 7 or 6. We could probably say the square root of 7, right? Which means if the square root of 7 is equal to 2.5, then the area, since the area must be approximately 7 meters squared. So if I take my calculator and say, what is the square root of 7? It's 2.6. If I say, what is the square root of 6? It's 2.4. It's probably closer to 6 than it is 7. But an area of 6 or an area of 7 are both good estimations for what the area must have been if the side length was 2.5. Okay. The actual side, the area, if you use a calculator, you could just take 2.5 and multiply it by itself. The actual area was 6.25 meters squared. But if we're estimating, anything from 6 to 7 would be sufficient.